dosage calculations. Okay, there's a little song I want y'all to sing in your head, because this is where students mess up when it comes to calculations, when we are talking about drops per minute and ml per hour. This is one thing. Okay. Drops per minute, mLs per hour, I want a whole number. Okay? Drops per minute, mLs per hour. I want both of these. I want a whole number. Okay? So when I say whole number, let's go and give actually I'm going to take this off. Let's give an example. I do my fun calculations. My answer comes out to be 18.21. What is my answer? 18. Whole number. Okay? Do another calculation. It comes out to be 65.794. Well, I'm going to look at my decimal, and at this time I'm going to look at over here to the right of it, and then I'm going to say that's my 5. But then I'm going to look to the left. Does my 7 affect my 5? Yes. So my answer is going to be 66. Do not, when you type in, do not say 65.794. That's not a whole number. Okay? Drops per minute, mLs per hour. I want a whole number. Drops per minute, mLs per hour. I want a whole number. Got it? Sing it. Live it. Learn it. That's from an old 80s movie, which y'all probably don't know what that is either. Okay. So I want to make sure that if it's asking drops per minute or mLs per hour, whatever I get, I need it to be a whole number. All right. Now, on the flip side, we're not going to do drops per minute and mLs per hour. Now we're just going to do mLs. Okay. So when I say mLs, what I mean is I've got my syringe. I have to draw up a certain amount of medication, all right, in a syringe before I go give it to my patient. So this is where the rounding rule is. We're rounding to the nearest hundredths. So let's do some of these. 0.896. Here's my decimal. First one is tens. Okay. Second one is hundredths. Make sure you know. Third one is thousands. Okay. So when I say we're going to round to the nearest hundredths, what does that mean? What am I going to do? All right. So what I'm going to look at is I'm going to say, all right, give me a second. Can anybody come up? Okay, so what I'm going to do is I'm going to look at this, all right? So, I did it. Okay, so here's my hundredths. I need to look at their friend that is to the left of them. Okay, is this friend going to affect this person? Yes or no?
Yes.
Okay, so it's going to make, this 6 is going to make this a what?
It's going to make it a 10, so a 0.
Okay, but see, I got a 0 there, but I have to put my 10, my 1 over where? So it's going to trickle down over here, and it's going to make this a
9.
9. So my answer is 0.9. No trailing zeros. Do not say 0.90 or you get it wrong. Do not say 0.9 or you get it wrong. It's 0.9. Let's do another one. 1.281. Tens, hundreds, thousands. There's my hundredths. Let's look at their friend. Is their friend going to affect them this time? Yes or no?
No.
No. So forget the friend. I'm getting them out of my life because I don't care about them anymore. Now my answer is 1.28. That's it. Let's do another one. 0.876. Tens, hundreds. Oh, let's look at their friend. Will their friend affect them? Yes or no?
Yes.
Yes.
Yes, so it's going to make this an 8. That 8 doesn't change anything. So my answer is 0.88. Got it? All right, let's do another one that's going to get a little tricky. I want to see if y'all can, let's do this one. 2 more real quick. 0.989. Tens, hundreds. Does their best friend affect them? Yes or no?
Yes.
Yes, so it's going to make it a 9. Do not round up to a whole number on this. Absolutely not. So my answer, I know it looks stupid. I know you're like, what's the difference between 0.99 and 1? It's a difference. So don't go, well, that's about 1. That's good enough. No, it's not. 0.99 is not the same as 1. Okay, one more. 0.998 tenths, hundredths. Look at their best friend. Does their best friend affect them? Yes or no?
Yes.
Yes. All right. So their friend's going to affect them. It's going to make this a 10. Oh, I got to do something with my 1. So now they're going to affect their other friend. Oh. Oh no, I still have to do something with the 1. So now it's going to have to go affect this friend. Oh, answer 1. And that's it. Not 1.00, not 1.0. It's 1. Again, this is when I'm going to have to ask you, how many mLs will you administer? That's when this rounding rule is. If it says drops per minute, mLs per hour, you want what?
Whole number.
Whole number.
Whole number. Got it? And that's where you just get that whole number. That's when you will look at the tenths. But that's it. That's it. Good?
Can you repeat that one more time?
Okay. Drops per minute, mLs per hour, I want a whole number. That's when, if my answer comes out to be 18.15, that's the only time where the tenths matter. Okay? That's when it doesn't affect this one at all, correct? The tenths. So my answer is 18. That's if the question says how many drops per minute or how many mLs per hour are you going to get, I need the whole number. If the question is asking you, I've got and Brian's going to do a couple of them, and it says how many mLs will you administer? Not mLs per hour, mLs. That's when you're going to do the rounding to the nearest hundredths. Okay? Good?
Yes, ma'am. Thank you.
Okay, you're welcome. All right, Brian, you ready? You next?
Am I up?
I think so. I thought that's all I was doing on this
Can
one.
they use calculators?
Yes. Oh, you will have a calculator that's built into your exam that you can use, FYI.
All right, welcome back. So what I'm going to do is just refer back to the practice test that you were given to practice your dosage calculation problems. Now, there is some feedback in the background, so just please make sure that you're muted. Okay, so what I want to say about dosage calculations is we can make this extremely easy as long as you know how to set the problem up. The majority of the work is setting it up, and then you have a calculator from there. So that's what we're going to concentrate on. But before we can do example problems, there's just some dosage calculation conversions that I want you to be aware of. And it comes to our medications when it comes to grams, milligrams, micrograms, okay? On this board, what I want to do is list largest to smallest. So you know, don't get confused. Our largest weight measure for a medication is going to be grams, correct? And you may see that small g on a test. You may see it GM, or you may see it large GM. That all means grams, and that's our largest unit, okay? Other medications come in milligrams, and there's what it looks like. And finally, some medications, especially with pediatrics, come in the smallest measurement known as microgram. Now, this is important that I put it largest to smallest to you, because when we start setting up our problems, all you ever have to remember to convert is that it is the rule of 1,000. So we'll be plugging that somewhere in our problem to convert to make it agree with our units of measure. But I'm going to say to you, always remember that the 1,000 goes with the smallest unit of measure. So you set your problem right. Now, that will make sense when I do some problems on the board. I'm going to say, where do I put the 1,000? And always remember in your brain, it goes with the smallest number. Okay, some other numbers real quick that I want you to remember. Some medications are dispensed in tablespoons, okay? And we know 1 tablespoon is equal to how many milliliters? That is 15. So 1 tablespoon is 15 milliliters. That means if I want 1 teaspoon, which is smaller than a tablespoon, I know that there are 3 teaspoons in 1 tablespoon. So I can fit 3 small spoons into your big soup spoon, okay? And that is 5 milliliters, is a teaspoon. Read your question carefully to decipher if it's tablespoon or teaspoon. The other one is ounces. We know 1 ounce in fluid form is equal to 30 milliliters, okay? And the final number I want you to know is kilograms for our weight problems. 1 kilogram is equal to 2.2 pounds, okay?
We
So
can't.
here, what?
We can't see it.
Can you
Thank
see
you.
it now? You won't be able to see my face because I'm too tall for this screen image, but I'm sure you can hear me because they report they can hear me on the moon. All right, now that you have your conversions listed out, are you ready? Let's do some example problems. But before we do the example problems, we must be able to set up our problem. Now, with our basic math problems, we already know your formula is always D over H, correct? Or desired over hand? I don't want you to remember that. I always want you to say D is for doctor, and the doctor is always on top. All right? Interpret that any way you will, as long as you remember that. So doctor's always on top, so whatever the doctor ordered is what our numerator is going to be. And what's available on the floor, the sky, the med cabinet is what you have available on hand. All right? All right, here we go. Now on your example problems, what I don't like about this practice test is it doesn't go easy to hard. They're just scattered all over the place. So I'm going to be skipping around, starting at the easiest type of problem and working our way to difficult. So number 4 says the physician has ordered penicillin 450,000 units IM. Available is penicillin 600,000 units per ml. How many milliliters will you give? Now you remember to set up this problem, which is the majority of getting this right, is setting it up correct. The doctor is always on top. So we're using our standard formula of doctor over on hand, which is available. The doctor's on top, and what did the doctor order? You know the doctor ordered 450,000 units. And please remember to always include your units so we can see if they match and agree. What's available on hand? What's available on hand is 600,000 units. Now, the nice thing about level 2 is you're allowed to use calculators, okay? Which means technology is only as accurate as the person entering the information. So please take your time and make sure that you're entering it into the calculator exactly. But before I do that, I am solving for milliliters in this problem. Units are on top. I can cancel that out, correct? And I'm left with milliliters is what I'm solving for. You can do this 2 ways. If you're using a calculator, the top number, which is the doctor, always gets entered into your calculator first. So you will enter 450,000 and make sure you have enough zeros divided by 600,000. So the numerator is first in your calculator. All right, moving on. The other way you can do this, if you like, is to work with this in more manageable numbers. Meaning, if there are zeros on tops and ending in zeros on the bottom, we can cancel out all our matching zeros, okay? And I'm left with, what am I left with? Okay, I'm left with 45 over what?
60.
Okay, so you can also do it that way, but if you don't want to remember that step, don't worry about it. Just enter the top number in your calculator first, divided by 600,000. Now, what is 450,000 divided by 600,000? We know on your calculator it will be 0.75. Now, your rounding rule, because this is a milliliter problem, is to the hundredth place, which Stacy said is 2 spaces to the right. Okay? Does it have a friend next door to it that Stacy said? No, it does not. It already factored out into the hundredths column, so you will leave it alone. Okay? Now, don't add a 0 because you just went from 75 to 750, okay? And if you don't have a 0 before the decimal, you add your leading 0, so it's 0.75. Leave it alone. Okay, next problem. Oh, this is fun. The next problem I would like to do is problem number 1, and this gets more difficult because we're going to have to do a conversion. And it says the physician has ordered 0.2 grams of an Equinol tab. The dose on hand is 400 milligram tabs. How many tabs do you give? All right, now it's like any other problem. You're doing D over H, and we are solving for tabs. They want to know how many tabs. So the doctor always goes on top. And what did the doctor order? 0.2 grams. And what is available or on hand? We know that 400 milligrams. Okay, now listen to me carefully. I look at my unit of measures and they do not agree. I have grams up top and I have milligrams at the bottom. So I must convert. And how I do this is they always go opposite each other. So grams started up top. To get rid of it, we have to put gram at the bottom. Milligram was at the bottom. I have to go opposite to put it on top. So they cancel out each other. Now, I have to know, is there 1,000 milligrams in a gram, or is there 1,000 grams in a milligram? Remember I told you at the beginning, how to remember this is 1,000 always goes with the smallest unit of measure. So from milligram to gram, which one's smaller, a milligram or gram?
Milligram.
Yeah, so the 1,000 always goes with whatever one is smallest. And that way, you'll never forget it, okay? So now let's look. Milligrams cancel out, grams cancel out, and what I'm left with is tabs, and that's what I'm solving for. Okay, now the nice thing about calculators is we'll start with the numerator, which is the top number, you can do 0.2 times 1,000 in your calculator, and that will come out as 200. Or if you plan on not using a calculator, I don't know why you would ever do that, but when there's 3 zeros, that just means move the decimal 3 times. So if I go 1, 2, 3, I end up with 200. Use your calculator, please. All right. And then my bottom numbers across is 400 times 1 or x, whatever you're using. So 400 times 1 is 400, okay? Now, like I said, which number are you going to enter in your calculator first? You know that's the top number, your numerator. So you will be doing 200 divided by 400, okay? And that number equals, all right, 0.5 tabs, meaning you're giving a half of a tablet. Now, if your calculator only did 0.5, what are you going to do? You never, ever add a trailing 0, but you will put your leading 0 as the placeholder. Because what physicians do, you can't read their writing, and their decimal looks like a 1, and the nurse gives 15. So that's why we need the 0 place number leading. But don't ever add trailing zeros. Wasn't that conversion fun? Now you always know where to put the 1,000. You always put the 1,000 with the smallest unit of measure. And I went from greatest to smallest before when we started, okay? All right, now let's do number 3 because that one has milliliters in it, but it's the same problem. The physician ordered streptomycin 250 milligrams IM, available as streptomycin 0.5 grams per 2 mLs. How many milliliters will you give? Well, it's the same exact problem because it's not an IV problem, right? We are just solving simply for milliliters. So it's always doctor over hand. So let's start there and make it simple. We know, what did the doctor order? The doctor is on top at all times. It's 250 milligrams, okay? And what is available on hand? I have 0.5 grams. Now, notice in this problem how they use GM. Sometimes it will just be a G. It's all the same. All right, now, but that's not all I have on hand, correct? Because it says in my math problem 0.5 grams per 2 mLs, correct? So where do I put the 2 mLs, at the top or at the bottom? It always has to go opposite, okay, from what you have on hand. So 0.5 gram per means opposite, and my 2 milliliters are now in my problem, correct? All right, so I set up my problem, but I look at my problem and look, I have milligrams and I have grams, which means I need to convert that as well. So to convert, remember what I said? They have to go opposite. So milligrams is now at the bottom, and you can bring grams at the top. And all conversions are a rule of 1,000. But I need to know, where am I putting my 1,000? With the grams or milligrams? Well, Brian told you the 1,000 always goes with the smaller unit of measure. So which one's smaller, grams or milligrams? And I know that is milligrams is smaller, so I know where my 1,000 is, correct? Oh, this is fun. All right, so let's start getting rid of units of measure if they cancel. Milligram up top, milligram on bottom. So I can cancel those. Grams on the bottom, and there's the gram up top. So I can cancel those. and the only one I'm left with is milliliters, and that is what I am solving for, correct? Which means you're on the right path. So all I have to do is math from here. So I'm going to take all my top numbers working left to right. 250 times 2 is 500. Then I go to the bottom row, working left to right, 0.5 times 1,000. Remember, you can move the decimal 3 times or use your calculator, and that also comes to 500. So 500, the top number, goes into your calculator first, and the bottom number is 500 as well. So 500 divided by 500 is 1. Now, that doesn't go to the hundredths column, correct? Well, you leave it alone. I don't have any information. It came out as a whole number, so don't start adding things because it's not a decimal problem. All right, moving on. All right, so can you remember for me that the doctor's always on top, and then you'll set all these problems up correct. All right, let's do a more difficult one, and it is a weight problem. And when it comes to weight, you already know the conversion that I gave you. Yes, Valencia, do you have a question?
No, no question. That was an accident.
Okay, thanks for the wave. All right. Now, number 5, it says the doctor has ordered Lovenox 1 milligram per kilogram subcutaneous daily. The patient weighs 143 pounds. How many milligrams are to be administered? Okay, so we want milligrams. What did the doctor order? The doctor has ordered 1 milligram per kilogram. When you have a weight problem, the very first step you will do before you plug it into your formula is that you will need to convert pounds into kilograms, okay? And I know that the patient weighs 143 pounds, correct? 143 pounds. However, I want kilograms. So pounds comes down, correct? Kilograms is at the top, so I can cancel. All right. There is 1 kilogram is 2.2 pounds. Okay. If you don't set it up longhand, you always know divide pounds by 2.2. That's how you get kilograms. So I know 143 goes into your calculator first. Okay, 143 divided by 2.2 is 65. So I have 65 kilograms, okay? Now, in your weight problem, okay, the doctor has ordered 1 milligram per kilogram. And per simply means multiply. So 1 milligram is what the doctor ordered per kilogram. But what's my new kilograms? And we said it was 65 kilograms, okay? So 1 times 65 is 65. That is your answer. So again, with the weight problem, take pounds first, divide it by 2.2, and times it by what the physician has ordered. All right. That is some basic problems when it comes to conversions from gram to milligrams, from micrograms to grams. You already know, put the 1,000 with the smallest unit. Doctor is always on top. Now it's time to turn our attention to the tricky part of dosage calculation, which will be your IV problems. Before we can start our IV problem, I need you to know what's going to be on top and what's going to be on bottom. Because if we can't set up the problem correctly, we're never going to get the right answer to begin with. So this will require you to remember a few items. So what I'm going to do is share my screen with you. All right, so on your screen, you can see drops per minute is up top, and that requires 3 items, okay? Now, what I want in the numerator, as you can see, which is the top number, is the amount to be infused. That's the number in your problem that contains milliliters. That's how much fluid is in that bag, okay? The other numerator number next to it is your drop factor. This is known as tubing. So you have to say, my tubing number also has to be up top. All right, now if you cannot remember this, or something goes wrong where you have anxiety during your test, all you have to say is time is always on the bottom. So for if you're doing drops per minute, of course I need that in minutes, and you know on a test I'm going to put it in hours, so we'll deal with that in 1 minute, okay? Time is always bottom. Everything else needs to be in the top when you set up your problem. All right, now look at formula number 2, which is milliliters per hour. It's the exact same setup, but easier. Because when I do milliliters per hour, I need the amount to be infused, which means milliliters. How many milliliters are in my IV bag? Okay. I do not use tubing. So of course your problems are going to have tubing in it, hoping that you use it. All right. There's no such thing as tubing for milliliters per hour. And then time, again, is always on the bottom. And we're solving for hours because it's milliliter per hour. So it must appear in hours. And of course, they're going to give you minutes, so you have to convert that out. Okay? So can you please write that formulas down, please? And if you can't remember any of it, just remember that time appears on the bottom. So let's do a few of these problems together. And I will do number 6. And now you understand why setup is, you know, the most important portion of this. All right, so the physician has ordered D5W 1,000 milliliters to be infused over 8 hours. The infusion set delivers 20 drops per milliliter. What is the infusion rate? Now, look at what they want me to solve. It's drops over minute. Remember, I draw my line and I say to myself, everything's on top with the exception of time. So the first number I want is milliliters, correct? How many milliliters are in my bag? It says the physician has ordered D5W 1,000 milliliters, okay? Now I have 1,000 milliliters in my bag is up top, okay? The next thing is drops per minute. So I have to remember from my formula that when it's drops per minute, I do have to use the tubing set number, correct? And that is 20 drops, right, 20? Yep, 20 drops per milliliter, okay? And time needs to appear on the bottom. And what time did they give me? They gave me 8 hours. All right, let's look at my problem. I set up my problem using all the numbers that I can. Milliliter and milliliters cancel out. So I'm left with drops over hours. Is that what I'm solving for, drops over hours? No, I need minutes, correct? So I'm running off the board, but you can see I drew another line. I need to convert this into minutes, correct? So to do that, I need to go opposite. So hours now needs to be on top and minute needs to be on bottom. 1 hour is equal to 60 minutes. So I can cancel out hours now, and I'm left with drops over minute, and that's exactly what I need, okay? So I'm going to take the top and go left to right, which is my numerator. 1,000 times 20 times 1, or 1,000 times 20 is 20,000. I need my numerator, which is left to right, 8 times 60, and that is 480. Which number do you put in your calculator first to divide? I need the top number. 20,000 divided by 480, and that comes out to 41.6. Now, guess what? This is an IV problem. And when you're looking at it drip 41.6 times, it's either a drip or it's not. So that's why all IV problems need to be whole numbers. I can't look at a drop of fluid and say, oh, that's 0.4. No, that's 0.3. No human can see that, right? So that's why all IV drops must be in whole numbers. So whole numbers is the number to the left of the decimal. So I need to look next door to the friend to see, do I go up or down? And anything greater than 5 or above, I'm going to round up. So this comes to 42 drops per minute. Okay? Oh, that was fun. All right. Let's do another, please. This one's a little difficult, but it's another number we're going to have to memorize, but I'm going to do number 7. And number 7 says the physician orders 300 milliliters of D5W to be infused over 3 hours. The IV tubing is a micro drip set. What is the drip rate per minute? Drops per minute. So if I remember my formula, all I need to know is time needs to be on the bottom. But I run into a little problem, but I'll deal with it when I get there. First number is my milliliters. How much fluid in milliliters is listed in that problem? It's 300 milliliters, correct? And this is drops per minute, which means I need the tubing. However, this question did not give you tubing, whether it was 10, 15, 20. They didn't give you a number. They said it's a micro drip tubing set. Well, there's only one type of micro drip tubing. And micro drip tubing is always 60 drop drops per milliliter, and you have to remember that one. Because since there's only one tot, they might tell you it's 60 drops per milliliter, or they may just say you're using micro drip. You need to know micro drip means 60 drops per milliliter, okay? Macro drip is 10, 15, 20, so they always have to give you the number, but there's only one type of micro drip tubing. Please remember the number 60. So I know now, since I'm using micro drip tubing, tubing goes on top because the only thing that goes on bottom is time. So that's drops per milliliter, correct? And how much time was in my problem? Over 3 hours, correct? So everything's on top except time. That's very good. All right, so let's look at what I'm dealing with. Milliliters can cancel out because they're on top of each other, and I'm left with drops per hour. Is that what I'm solving for? No, it is not. I need minutes at the bottom, but it's hours. So I go opposite. Hours is now on top. Minute is on the bottom. 1 hour is equal to 60 minutes. Hours cancels out, and I'm left with drops per minute. So again, now it's basic mathematics, left to right, starting with the top numbers. 300 times 60 in your calculator. 300 times 60 will be 18,000. And 3 times 60 is 180. So which number now I need to divide? Which number goes in your calculator first? You know that's always the top number. So it's 18,000 divided by 180, and that comes out to 100 drops per minute. Is that a whole number? Yes, it is, because it contains no decimal. So leave it alone. All right, are you ready? Let's try a milliliter per hour, which is even easier. All right, per minute is harder because you have one more number in the problem. So let's just do number 8, please. The physician has ordered 150 milliliters to be infused in 45 minutes. What would be the rate be in milliliters per hour? So I have milliliters per, which means over, correct? Milliliters per hour. I can't remember what Brian said because I'm too nervous, but all I know is that time always goes on the bottom, so that means everything else is up top. Milliliters up top, how much fluid do I have in that bag? I have 150 milliliters, correct? Now, what else is in that problem? To be infused over 45 minutes. Time always goes on the bottom. And lucky for us, they didn't include the tubing, and we don't use tubing anyway for milliliters per hour. So I have all the information I need. But you can see it's milliliters over minute. Can I do that? No, it wants milliliters per hour. So to be able to get over minutes, I bring it up so it cancels. All right. I need to say there are 60 minutes in 1 hour. So I cancel minute, minute, and I'm left with milliliters, which I need, and hour, which I need. So I'm good to go. Let's do our top numbers. 150 times 60 is 9,000. And my bottom numbers is 45 times 1 is 45. Now I must divide. 9,000 divided by 45. 9,000 goes in your calculator first. And I'm left with 200. Is that a whole number? You don't see no decimal in there, so leave it alone. Okay. Oh, this is much simpler than I thought it was going to be. So let's make this difficult. Oh, let's just go on to 9. There's a whole lot going on in 9. The physician ordered lactated ringers 1 liter to be infused over 6 hours. The administration set delivers 10 drops per minute. How many milliliters per hour are to be administered? All right, so the very first thing, you don't panic because there's a bunch of numbers. We're just going to use the same processes that we've always used. I am solving for milliliters per hour, correct? In milliliters per hour, how much do I have in that bag? Remember, the bag has to be in milliliters. However, this is 1 liter. So you already know, if you can't remember any numbers anymore because you're overwhelmed, you always know most conversions, 9 times out of 10, is the rule of 1,000. So 1 liter is 1,000 milliliters, okay? So 1,000 milliliters over to be infused over 6 hours. Where does time go in my formula? Always on the bottom, correct? The administration set delivers 10 drops per minute. Where do I put 10 drops per minute? Remember, I had you write down and memorize those 2 formulas? You do not use tubing for milliliters per hour. The only time you're using tubing is drops per minute. So we can't use tubing in this problem, so I need you to ignore it. It's there to distract you, okay? And this simply says, how many milliliters per hour? Is that what I have? I have milliliters on top, and I have hours on bottom, and that's exactly what I'm solving for. So this simply says 1,000 divided by 6, okay? Which number goes in your calculator first? The top number, 1,000 divided by 6. And that comes to 166.6667 repeating, okay? So let's just say to ourselves, there's no such thing as 0.666666 of a drop. It's either a drop or it's not, okay? There's no such thing as some of a drop. I either see it or I don't. All right, whole number. We know whole numbers are left to the decimal, so I need to go next door to the friend, and it's 5 or greater, which means I will round up. It is now 167 milliliters per hour. Now, the only reason this problem was difficult is because it provided you the drip tubing, and you do not use tubing for milliliters per hour. All right? The hint is the other problem you're solving is drops per minute. Well, the tubing is listed with drops, so you know you have to use it, correct? But there's no GTTF anywhere in milliliter per hour. Isn't that fun? All right, let me just see. The rest are basic problems.
No.
All right, now, is there a problem on your sheet that you would like that I didn't do that you would like me to do out? Was this helpful to set it up? I don't care what you do, but you better put time on the bottom. All right, the other problem is, I don't see there's an example of it here, but another problem is they'll tell you the doctor ordered 3.336 grams of Zosyn in 100 milliliters of normal saline to be infused over 5 hours, all right? Where are you, if it's an IV problem, where are you putting the 3.3375 grams?
On the top?
No, there's no such thing. Because all I'm doing with an IV is I'm dealing with the IV fluid. I don't care how much medicine is it. All I can deal with is the fluid in that bag. So you saw in your formula, the only thing going up there is milliliters. So if it said you had Zosyn 3.375 grams, it doesn't matter to me. There's no room on this formula to deal with milligrams. When we're dealing with IVs, we only deal in fluid, and milliliters is your fluid. Does that make sense?
Yes.
So don't plug in numbers that you're not supposed to be plugging in. That's where the errors come in. All right, now listen, there's one last thing I have to tell you, and it upsets me. And most of you who will not pass is because it's a foolish error. And that means that I need you to read carefully and pay attention to the terminology in your question. Because when it comes to terminology in your question, there will be terms such as, what is contraindicated when given this medication? What does contraindicated mean? You means you cannot give it, you're looking for something bad, okay? Now, for some people who are nervous, they read that and they interpret that as, why am I giving it? That's not what that says at all. So if it's contraindicated, it's asking, why can't you give it? What is wrong? Another terminology is, say, what is the therapeutic effect? Therapeutic is beneficial. Why are you using that medication? So I don't know why you're confusing therapeutic with contraindicated versus, I don't know why you're doing that. But pay attention. Therapeutic versus contraindicated. I don't know why people think contraindicated means, why am I giving it? That's not what that means at all. What's the indication for this medication? Indication means, why are you giving that medication? Contraindication means, why can't you give it? All right. All right, so usually a student who gets a med problem wrong, I'll say, why did you give it? Oh, I misinterpreted contraindicated. Oh, please, I'm not having it. Quit farting around. All right, Stacy, do you have anything to add?
Nope. Are y'all good? This has been 3 hours. Y'all better pass that test the first time.
That was way too long.
First time y'all pass, right? Everybody?
Yes, hopefully.
Okay.
Enter